Have you ever looked up at the stars and felt something deeper than just wonder? That flicker of recognition, as if the cosmos itself understands what it means to ache, to yearn, to endure. The universe isn't just a vast, indifferent expanse, it's alive with stories that echo our own. Out there, in the infinite dark, stars explode in acts of self-destruction that mirror our darkest moments. Galaxies collide in violent embraces, their gravitational dances reminiscent of love and loss here on Earth. Even black holes, those enigmatic voids, seem to grieve as they devour light itself. These aren't just random events, they're cosmic reflections of the human experience, written across the heavens in fire and shadow. Think about it. When a massive star reaches the end of its life, it doesn't fade quietly. It erupts in a supernova, a cataclysmic finale so powerful it outshines entire galaxies. In that blinding flash, there's a strange beauty, a reminder of how even destruction can birth something new. Isn't that just like us? How often have we faced our own personal collapses, only to find strength in the aftermath? Or consider binary star systems, locked in an eternal orbit, their fates intertwined. One might siphon away the other's energy, a celestial metaphor for relationships that drain us, leaving us dimmer versions of ourselves. The universe doesn't just mirror our emotions, it magnifies them, showing us the grandeur of our own struggles on a scale we can barely comprehend. This isn't just about astronomy, it's about connection. When we see a nebula cradling newborn stars like a mother holding her child, or a rogue planet wandering alone through the interstellar void, we're seeing pieces of our own stories reflected back at us. That's why today we're diving into 25 of the most emotionally charged events in the cosmos, each one a parallel to the crises, triumphs, and heartbreaks we face here on Earth. By the end of this journey, you won't just see the universe differently, you'll see yourself differently too, because the line between the heavens and the human heart, it's thinner than you think. There's something haunting about a neutron star left alone in the void. These incredibly dense remnants of massive stars, no wider than a city yet weighing more than our sun, are already strange and extreme by nature. But when one loses its companion, a star torn away in the violence of a supernova, what remains is more than just a celestial oddity. It becomes a portrait of cosmic loneliness. Picture this, a spinning beacon of crushed matter, its surface a solid crust of iron, yet beneath that unyielding exterior pulses a heart of unimaginable density. It emits rhythmic radio waves steady as a metronome, but each pulse carries the weight of absence. Scientists call these orphaned stars isolated pulsars, but that clinical term doesn't capture their emotional resonance. Their pulses slow over millennia like a clock winding down, as if even time itself grows weary of their solitude. What makes their story so poignant is how closely it mirrors our own experiences of loss. A neutron star in a binary system shares its life with another star, their gravitational embrace shaping their destinies. But when one explodes, the survivor is left adrift, its magnetic field, once intertwined with its partners, now stretching outward into nothingness. It's a cosmic parallel to the way grief lingers, how the absence of someone we love can feel like a presence all its own. And just like a person grappling with heartbreak, these stars don't fade quietly. They sometimes emit eerie glitches, sudden changes in their rotation, as if caught off guard by a memory. Even in the cold equations of astrophysics, there's room for haunting beauty. The universe has a way of turning destruction into something strangely poetic. The same supernova that ripped these stars apart also scattered heavy elements, carbon, oxygen, iron across space, the very building blocks of planets and life. So while one story ends in solitude, another begins with possibility. Yet that doesn't dull the ache of the neutron star's endless spin, its light years of empty space echoing with signals no one may ever hear. It's a reminder that loneliness isn't just a human condition. It's woven into the fabric of the cosmos itself, written in the slow, fading pulses of a star that once had someone to orbit. There's a quiet tragedy in watching a star die, not with a whimper, but with a roar that echoes across millennia. Take Beetlejuice, that fiery red giant in Orion's shoulder, a star so massive its final act will be visible from Earth even in broad daylight. Right now, it's in its twilight years, puffing and heaving like a weary traveler struggling up a hill. Its outer layers swell unpredictably, sometimes dimming dramatically as if catching its breath, other times burning brighter in fits of defiance. Astronomers call this the pre-supernova phase, but strip away the clinical language and what you're left with is something profoundly human, a being fighting against the inevitable. What makes Beetlejuice's story so gripping isn't just the spectacle of its impending death, it's the way its struggle mirrors our own. When faced with mortality, whether stellar or human, there's a universal tension between surrender and resistance. The star's core, once a bustling factory of nuclear fusion, now churns unevenly, its fuel running low. Yet even as it weakens, it does something extraordinary. It begins forging heavier elements in its final furnace: carbon, oxygen, even the iron in your blood. These elements will one day be catapulted into space in a supernova so brilliant it could outshine the moon. The very atoms of its demise become the seeds of new planets, new life. It's a cosmic metaphor for legacy, for how our darkest moments can unknowingly plant forests we'll never sit under. And here's the beautiful paradox: Beetlejuice's death will be its most luminous act. When it finally explodes, that flash of light won't just be an ending, it'll be a beacon, visible for centuries, guiding astronomers and poets alike to ponder the fragile, fleeting nature of existence. Ancient civilizations once mistook supernova for omens, but today we understand them as something even more profound, reminders that destruction and creation are two sides of the same coin. Every time we look up at Orion and see that familiar red glow, we're witnessing a star in its final act of generosity, spending its last reserves of energy to remind us that even in death, there's a kind of immortality. The stardust it leaves behind will one day swirl into new solar systems, perhaps even new creatures who will gaze up at their own sky and wonder, just as we do, about the stories written in the stars. Black holes are the universe's most paradoxical creatures, simultaneously terrifying and mesmerizing. They don't just consume, they warp reality itself, bending space and time until the rules we know no longer apply. At their edge lies the event horizon, that invisible boundary where gravity becomes so strong even light can't escape. It's a point of no return, a cosmic metaphor for the moments in life when we cross a line, whether into obsession, addiction, or any hunger so consuming it threatens to swallow us whole. Yet here's the twist: even in their relentless devouring, black holes aren't just voids. Somewhere in that chaos, particles are wrenched apart, and energy erupts in dazzling jets that streak across galaxies at nearly the speed of light. These aren't just explosions, they're beacons, proof that destruction and creation are locked in an eternal dance. Think about Sagittarius, a star, the supermassive black hole at the center of our Milky Way. Its gravitational pull is so immense it orchestrates the orbits of billions of stars, a silent puppeteer in the cosmic dark, but occasionally it does something extraordinary. When a star wanders too close, it's torn apart in a process called spaghettification, stretched into thin streams of gas before vanishing. Yet, from that annihilation comes something unexpected, a brilliant flare of X-rays, a burst of energy so intense it can be detected across the universe. It's as if the black hole, in the act of consuming, also gifts the cosmos with light. This duality mirrors our own struggles. How often have we been dragged into the depths of a craving, only to emerge with newfound clarity? How many artists, scientists, or even ordinary people have turned their darkest obsessions into something luminous? And then there are quasars, the universe's most powerful lighthouses. These are black holes so voracious they outshine entire galaxies, their jets piercing the darkness like cosmic searchlights. What's astonishing isn't just their brilliance, but their source. The very act of feeding fuels their radiance. It's a reminder that even the most insatiable hungers, whether in the stars or in ourselves, can become catalysts for transformation. The matter that escapes a black hole's grip doesn't just vanish, it's remade, accelerated into something new. That's the haunting beauty of these cosmic monsters. They don't just take, they reshape. They don't just end, they begin. So when you hear about a black hole's hunger, remember, it's not just a lesson in destruction. It's a testament to resilience. The same forces that drag matter past the point of no return also hurl light back into the universe. Maybe that's why they fascinate us so deeply. They're not just mirrors of our darkest impulses, they're proof that even in the grip of what consumes us, there's potential for light to break free. Galaxies aren't solitary islands in space, they're social creatures, drawn together by gravity in a dance that spans billions of years. Picture the Milky Way and Andromeda, two cosmic titans hurtling toward each other at nearly 250,000 miles per hour. It sounds like a catastrophe, and in many ways it is. When they finally collide in about 4 billion years, the chaos will be unimaginable. Stars will be ripped from their orbits, flung into the void like leaves in a storm. Gas clouds will compress, ignite, and birth new stars in fiery bursts. The elegant spiral arms we recognize today will twist and warp beyond recognition. Yet for all the violence, something extraordinary emerges from the wreckage, not destruction but transformation. This isn't just a celestial spectacle, it's a mirror to our own lives. How many times have you faced a moment where everything familiar was upended? A job loss, a breakup, a move to somewhere unknown. Like those stars tossed into uncharted space, we're left disoriented, untethered. But here's the cosmic truth: upheaval isn't the end. When galaxies collide, they don't annihilate each other. They merge, creating something entirely new, a hybrid galaxy, richer and more complex than before. The same holds true for us. Those moments that feel like endings, they're often the raw materials of rebirth. Consider the Hubble Space Telescope's stunning images of colliding galaxies. In their tangled cores, you'll find regions glowing with newborn stars, forged from the very chaos that could have obliterated them. It's a reminder that growth often requires disruption. The universe doesn't cling to what was, it embraces what could be. Andromeda and the Milky Way will eventually settle into a single, elliptical galaxy, one that might look nothing like its parents, yet carries their legacy forward. There's a quiet poetry in this cosmic resilience. Stars might be flung into the darkness, but they don't vanish. They adapt, finding new paths. Gas clouds might collapse, but from that pressure comes light. It's the same alchemy that turns our own struggles into strength. So the next time life feels like a collision course, remember, you're not just surviving the chaos. You're part of something far grander, a process as old as the universe itself, where destruction and creation are forever intertwined. The cosmos doesn't fear change. It thrives on it, and so can we. Imagine wandering through an endless night, untethered from everything you've ever known. No sunrise to warm you, no horizon to guide you, just the cold, infinite dark. That's the reality for rogue planets. Cosmic nomads cast adrift from their solar systems, condemned to drift between the stars. These aren't just celestial oddities, they're haunting reflections of our own deepest fears, of being unmoored, forgotten, left to navigate the void alone. Scientists estimate there could be billions of these orphaned worlds in our galaxy, each one a silent testament to cosmic upheaval. Some are flung away by gravitational chaos during their solar system's infancy, like children pushed from a crowded table. Others are stolen by passing stars, ripped from their orbits in a celestial game of tug-of-war. What's chilling isn't just their exile, but how they endure. Without a sun's warmth, their surfaces freeze into wastelands, their atmospheres collapsing like deflated balloons. Yet somehow, against all odds, some cling to traces of heat deep within their cores, a faint ember of resilience in the eternal cold. There's a heartbreaking duality to their existence. On one hand, they're relics of destruction, evidence of the universe's indifference. On the other, they're pioneers. Recent discoveries suggest some rogue planets might harbor hidden oceans beneath icy crusts, kept liquid by tidal forces or radioactive decay. These buried seas could, in theory, host life extremophiles thriving in perpetual night, proof that even in exile, survival finds a way. It's a cosmic parallel to the human spirit. How often have we seen refugees, migrants, or those cast out by circumstance forge new meaning in the wilderness? How many artists, thinkers, and survivors have turned their isolation into a crucible for reinvention? Consider the rogue planet CFPD Sir 2149, drifting just 100 light-years from Earth. It's a failed star, too small to ignite fusion, yet too massive to belong with planets. Neither here nor there, it exists in limbo, much like those moments in life when we feel too broken to fit our old world, but not yet whole enough to claim a new one. And yet, these worlds aren't truly lost. They're part of the galaxy's hidden architecture, their gravity subtly shaping the paths of stars they'll never meet. Invisible threads still bind them to the whole. Perhaps that's the most profound lesson these wandering worlds offer. Exile doesn't erase your place in the universe, it redefines it. A rogue planet might never again bask in a sun's glow, but it carries the elements of its birth within it, the same stardust that once swirled around its parent star. In that way, it's never truly alone, and neither are we. Whether by choice or chance, when we find ourselves untethered, we're not just adrift, we're in motion, part of a grander story still being written, one where even the loneliest wanderer has a role to play. There's a raw, aching beauty in the way a star dies, not with silence, but with a thunderous farewell that echoes across the cosmos. A supernova isn't just an explosion, it's the universe's most extravagant act of generosity. When a massive star reaches the end of its life, it doesn't simply fade away. It tears itself apart in a cataclysm so violent, it outshines entire galaxies for weeks. But within that chaos lies a paradox. Destruction becomes creation. The star's core collapses, its outer layers blast outward, and in that fiery crucible, atoms fuse into elements heavier than iron, carbon, oxygen, gold, even the calcium in your bones. These elements are hurled into space like cosmic confetti, destined to become the building blocks of planets, oceans, and life itself. Take the Crab Nebula, that swirling remnant of a supernova witnessed by Chinese astronomers in the year 1054. Today, nearly 1,000 years later, its filaments still glow with the energy of that long-ago explosion. But here's the miracle. Those same filaments are rich with complex molecules and dust raw materials for new stars and planets. The nebula isn't just a graveyard, it's a nursery. The star's death didn't just leave ruins, it left a legacy, and in that legacy we find a mirror to our own existence. How many parents have poured their last reserves of strength into giving their children a future? How many artists, thinkers, or ordinary people have burned brightly in their final moments, leaving behind something that outlasts them? This isn't just physics, it's poetry. A supernova's sacrifice echoes the quiet, everyday heroisms we often overlook. That teacher who stayed late to ignite a student's curiosity, the parent who worked double shifts to fund a dream, the activist who planted trees they'd never sit under. Like the star, they might never see the full impact of their actions, but the universe remembers. The iron in your blood, the silicon in your phone, the oxygen in your lungs, all of it was forged in the heart of a dying star billions of years ago. You are quite literally made of stardust, and that's the profound truth hidden in these explosive deaths. A supernova doesn't just scatter elements, it scatters possibilities. The same blast that could have erased everything instead sows the seeds for what comes next. It's a reminder that even in our darkest moments, when we feel spent, shattered, or at the end of our rope, we might unknowingly be laying groundwork for futures we'll never see. The Crab Nebula's light still reaches us, a message from a star that died before human civilization began. Its story isn't over, and neither is yours. Some stars don't just share the night sky, they share their very lives, locked in an intimate gravitational embrace. Binary systems where two stars orbit a common center should be celestial love stories. But not all cosmic unions are equal. In some pairs, one star grows bloated and ravenous, siphoning gas from its companion in a slow, insatiable theft. The donor star, stripped of its outer layers, grows faint and shrunken, while the thief becomes engorged, burning brighter with stolen fuel. It's a haunting parallel to the one-sided relationships we've all witnessed or endured, where one person thrives while the other withers. Take the system of Mira, a variable star in the constellation Cetus. Mira A, the larger star, pulsates erratically, its brightness swinging wildly as it cannibalizes its smaller companion, Mira B. The stolen material spirals into an accretion disk around Mira B, glowing with the heat of betrayal. But here's the twist: the victim doesn't always go quietly. In extreme cases, the donor star, drained past its breaking point, can collapse and explode in a supernova, a final, cataclysmic act of defiance. The same stolen material that fed the thief becomes the bomb that destroys them both. It's a cosmic lesson in consequences, a reminder that exploitation often carries its own destruction. This isn't just astronomy, it's a mirror. Think of friendships where one person always takes, or partnerships where emotional labor flows only one way. The imbalance might seem sustainable at first, until it isn't. Like those stars, the giver's light dims, their energy depleted, while the taker blazes on, oblivious or indifferent. But resentment, like gravity, has a way of asserting itself. The moment of reckoning might not be as dramatic as a supernova, but the emotional fallout can be just as transformative. Yet, even in these lopsided dances, there's nuance. Some binary systems reach an equilibrium, a fragile truce where both stars stabilize, forever changed but still together. Others spiral apart entirely, their bond severed by the weight of what was taken. The universe doesn't judge these outcomes, it simply unfolds them, offering no moral except the one we choose to see. And perhaps that's the most profound takeaway. Whether in stars or human hearts, imbalance rarely lasts. Sooner or later, the scales tip. The only question is whether both parties survive the rebalancing. Quasars are the universe's most dazzling illusions, beacons of light so intense they outshine entire galaxies, yet born from the darkest corners of existence. At their heart lies a supermassive black hole, a cosmic predator devouring everything that strays too close. But here's the paradox: as matter spirals toward oblivion, it doesn't vanish quietly. Friction heats it to millions of degrees, transforming it into a swirling, luminous disk that blasts energy across the cosmos. These jets of radiation can stretch for millions of light years, visible from the edge of the observable universe. It's a spectacle of light rooted in destruction, a brilliance forged from desperation. This cosmic contradiction mirrors something deeply human. How often have we witnessed someone radiating confidence while hiding a storm beneath the surface? The colleague who delivers flawless presentations but battles crippling self-doubt. The friend whose laughter rings loudest while they're drowning in silence. Quasars embody that same duality. Their light isn't a sign of health, but a cry for help written in photons. The brighter they blaze, the more voraciously their black hole feeds. It's a haunting reminder that not all light is joyful. Some is the last gasp of something being consumed. Take the quasar 3C273, one of the first ever discovered. Its light traveled 9 billion years to reach us, a message from the early universe. But that light isn't just information, it's evidence of a relentless hunger. The black hole powering it devours the equivalent of 10 suns every year, yet the quasar's brilliance masks that violence. From a distance, it's a pinprick of beauty. Up close, it's chaos. Isn't that the cruel irony of so many human struggles? The more we achieve, the more we sometimes sacrifice. The grander the performance, the heavier the cost. Yet quasars aren't just cautionary tales. They are also agents of change. Their energy can sterilize entire galaxies, but it can also trigger star formation in neighboring clouds of gas. In their wake, destruction and creation intertwine. It's a cosmic echo of how our own lowest moments can unknowingly inspire others. Think of the artist who channels grief into work that moves millions, or the survivor whose honesty about their pain becomes a lifeline for strangers. Even in our darkest hours, we emit light not despite the struggle, but because of it. Perhaps that's the quasar's most profound lesson. Its light isn't a lie, it's a testament. A declaration that even in the grip of something devouring, there's power to be found. The universe doesn't judge the source of the glow, only the fact that it exists. So when you see someone shining brilliantly, remember, their light might not mean what you assume, and when you're the one burning bright while feeling hollow, know this. You're not an illusion, you're part of an ancient celestial pattern, one where darkness and light are forever entwined. There's a ghostly presence shaping the cosmos, one we can't see, touch, or even detect directly, yet its fingerprints are everywhere. Dark matter, that enigmatic substance making up roughly 27% of the universe, doesn't emit light or interact with ordinary matter in any way we can observe. It's the ultimate silent partner, its existence only betrayed by the way its gravity tugs at stars and galaxies, bending their paths like an unseen hand guiding a marionette. This cosmic phantom doesn't just linger at the edges of existence. It weaves through every galaxy, every cluster, the very fabric of space-time itself. And in its stubborn invisibility, it mirrors something achingly human, the emotional burdens we carry but never name. Think of how a spiral galaxy rotates. Without dark matter's gravitational glue, its outer stars should fling into the void, torn loose by centrifugal force. Yet they hold fast, orbiting as if anchored by something we can't see. It's eerily reminiscent of how unspoken grief or quiet anxiety can shape a life invisible to outsiders, yet exerting a pull so strong it alters the trajectory of everything. A parent masking depression to shield their children, a partner swallowing doubts to keep peace, a child internalizing failure rather than disappoint others. These are the dark matter of the human experience, unseen, unacknowledged, but undeniably real in their consequences. Scientists have spent decades chasing this cosmic enigma, building detectors deep underground to catch phantom particles, mapping distortions in starlight to trace its distribution. Their frustration is palpable. How do you study something that refuses to engage? Yet their persistence mirrors our own searches for hidden truths. Therapy sessions spent excavating buried trauma, late-night conversations where a friend finally voices a long-held fear, the quiet moment someone admits, "I've been carrying this alone." Like astronomers piecing together clues from shadows, we too learn to read the gravitational ripples of unspoken pain in averted eyes, forced smiles, or sudden changes in behavior. What makes dark matter so haunting isn't just its mystery, it's how essential it is. Remove it and galaxies would fly apart. The universe as we know it wouldn't exist. Similarly, those silent struggles we dismiss as just part of life often hold entire worlds together. The single mother working double shifts without complaint, the caregiver hiding their exhaustion, the artist channeling heartbreak into work that moves strangers. Their unseen labor, like dark matter's gravity, is the scaffolding of so much beauty. Yet there's hope in this analogy. Just as scientists now use dark matter's influence to map the cosmos, we're learning to recognize the weight of unspoken stories by how they bend the light around us. A sudden withdrawal, an unexpected outburst, a pattern of self-sabotage, these are the gravitational lensing of the soul, distortions that point to something hidden. And when we dare to ask, what's really holding you up, we do what astronomers do. We illuminate the invisible by honoring its effects. The universe reminds us daily that absence can have mass. That what we don't say still matters, that sometimes the most powerful forces are the ones we feel but cannot see. Imagine watching the world speed by in fast forward while you stand still, every second stretching into years for those you love. That's the eerie reality of time dilation, a consequence of near-light speed travel where astronauts experience time slower than everyone on Earth. A voyage that feels like mere months for them could span decades back home. They'd return to a planet where friends have aged, children have grown, and the world has moved on without them. It's not just a quirk of physics, it's a profound metaphor for how life's upheavals can fracture our sense of belonging, leaving us stranded in emotional time zones no one else shares. Consider the hypothetical journey of an astronaut accelerating to 90% the speed of light. For every year they spend in transit, over 2 years pass on Earth. A 5-year mission would mean returning to a decade's worth of change, new technologies, shifted politics, maybe even the loss of someone they held dear. But the true weight of this isolation isn't in the numbers, it's in the disorientation of homecoming. Streets once familiar now feel alien, inside jokes fall flat, and the rhythm of daily life beats to a tempo they can't quite match. This isn't science fiction, it's the visceral reality of grief, trauma, or even long-term illness, where the world keeps spinning while you're trapped in slow motion. The parallels run deeper than mere loneliness. Time dilation forces astronauts to confront a paradox. They've witnessed the universe's grandeur firsthand, yet that very experience walls them off from the people they left behind. Soldiers returning from war, refugees rebuilding in foreign lands, or even survivors of personal tragedies know this duality intimately. Their journey changes them in ways that don't translate, leaving a chasm between their reality and everyone else's. Like the astronaut watching Earth's timeline accelerate from afar, they often describe feeling like observers to their own lives, unable to bridge the gap between who they were and who they've become. Yet there's a quiet rebellion in this struggle. Just as relativity bends time, human resilience bends alienation into connection. Astronauts train for re-entry, learning to anchor themselves in small rituals, photographs, music, the taste of a once favorite meal. Trauma survivors do the same, piecing together new routines that honor both their past and present selves. The dissonance never fully vanishes, but it becomes a language of its own, a way to navigate two worlds at once. Perhaps that's the lesson hidden in Einstein's equations. Time may be relative, but the need to belong is universal. And sometimes the bravest thing we can do is step back into a timeline that no longer feels like home, trusting we'll find our rhythm again. Beneath Europa's frozen crust lies an ocean darker than midnight, deeper than Earth's grandest trenches, a liquid realm sealed under miles of ice so thick it could crush submarines like paper. This tiny moon of Jupiter shouldn't harbor liquid water. It orbits in the bitter cold of space, where temperatures plunge hundreds of degrees below freezing. Yet there it is, a hidden sea kept liquid by the relentless gravitational squeezing of Jupiter itself, its tides flexing Europa's core like a stress ball. The ice above isn't smooth and unbroken, it's a fractured labyrinth, crisscrossed with rusty red streaks scientists call lineae, scars where the crust has cracked and refrozen. These aren't just geological features, they're cosmic metaphors for the way pain and pressure can fissure even the coldest exteriors, revealing the warmth beneath. What makes Europa's secret ocean so poignant isn't just its existence, it's what might live there. In the absolute darkness, under crushing pressure, and without a single ray of sunlight, hydrothermal vents could be spewing minerals into the water, creating oases for microbial life. The same vents exist on Earth's ocean floors, thriving with creatures that never see the sun: blind shrimp, translucent worms, bacteria that feed on chemicals rather than light. If life exists in Europa's abyss, it would prove something extraordinary. That hope persists even in the most inhospitable places. It's a mirror to the human experience. How often have we seen someone with a stern demeanor, all sharp edges and silence, who later reveals a hidden depth of compassion? Or met someone weathered by hardship, yet still capable of astonishing tenderness? The cracks in Europa's ice tell their own story. When the Galileo spacecraft first photographed them, scientists were stunned by their coloring, not pristine white, but stained reddish-brown. The leading theory, salt from the ocean below, laced with organic compounds seeping up through the fractures. It's as if the moon is bleeding its secrets, the very wounds revealing what lies beneath. There's a raw honesty in that imagery. So many of us build walls to protect our vulnerabilities, only to find those walls develop fault lines. A sudden confession during a late-night conversation, an unguarded moment of laughter after loss, tears that finally break through a carefully maintained composure. And here's the most breathtaking part: Europa's ocean isn't alone. Ganymede, Callisto, even Saturn's moon Enceladus all hide similar seas, their surfaces frozen masks over liquid hearts. The universe seems obsessed with this duality: hard shells guarding soft centers, ice preserving fire. Psychologists call this emotional armoring, the instinct to shield our most sensitive parts behind layers of defense. But Europa teaches us that armor isn't impenetrable. Tides rise, pressure builds, and sometimes the very forces that seem to constrain us, the Jupiters in our lives, the gravitational pulls of circumstance, are what keep our inner oceans from freezing solid. Perhaps that's why missions like Europa Clipper fill us with such anticipation. When it launches in the coming years, it'll scan those crimson cracks, analyze the chemistry of those plumes, and maybe, just maybe, find evidence that we're not alone in turning hardship into habitat. Because if life can flourish in a sunless sea under miles of ice, what does that say about the resilience hidden in your own guarded depths? The universe is whispering a secret. Beneath every surface, no matter how frozen, there are currents still moving, waiting for the right moment to rise. There's a quiet revolution happening in the depths of space, one where death doesn't have the final word. Nebulas, those luminous clouds of gas and dust, are more than just cosmic artwork. They're celestial recycling plants, transforming the wreckage of dead stars into the raw materials for new ones. Take the iconic pillars of creation in the Eagle Nebula, towering columns of cold hydrogen and dust where gravity works its slow magic. These aren't just static sculptures, they're active construction sites. Inside those dense, light-year-high pillars, pockets of gas collapse under their own weight, heating up until nuclear fusion ignites. A star is born. But here's the haunting truth. Those same pillars are being eroded by the very radiation from the newborn stars they cradle. The act of creation is also an act of destruction, a paradox as old as the universe itself. This cycle mirrors the most profound human experiences of renewal. Think of a forest after a wildfire charred earth giving way to seedlings that couldn't have sprouted without the heat of the flames. Or consider how personal reinvention often follows loss, how the end of a relationship, a career, or even a life chapter can become fertile ground for something unexpected. Like the elements forged in a supernova, carbon, oxygen, iron, scattered across space to eventually form planets, our own shattered moments contain the building blocks of what comes next. The grief that feels like an ending, it might be the soil in which resilience takes root. The Helix Nebula offers another striking example. 700 light-years away, this dying star has expelled its outer layers in a shimmering blue and red halo, while its exposed core, a white dwarf, glows like a cosmic ember. But look closer, that expelled material is rich with complex organic molecules, including water and carbon compounds. The very process of the star's death is seeding future possibilities. It's a celestial echo of how our own endings, failed projects, abandoned dreams, even the passing of loved ones, leave behind intangible legacies, lessons, memories, or simply space for something new to grow. What makes these stellar nurseries so emotionally resonant isn't just their beauty, it's their defiance. The universe could have been a place where death meant only emptiness. Instead, it designed a system where every ending pays forward. The oxygen we breathe, the iron in our blood, even the calcium in our bones, all were forged in the hearts of stars that no longer exist. We are quite literally the universe's way of turning loss into legacy. So when you gaze at images of the Carina Nebula's swirling colors or the Orion Nebula's glittering stellar infants, remember, you're not just looking at stars being born. You're witnessing the cosmos' oldest alchemy, the art of beginning again. Pulsars are the universe's most precise timekeepers, spinning remnants of dead stars that flash like cosmic lighthouses with a rhythm so exact their pulses rival atomic clocks. These collapsed cores, barely the size of a city yet denser than the sun, rotate hundreds of times per second, their beams sweeping across space with metronomic consistency. Astronomers use them to navigate spacecraft, test Einstein's theories, even map the galaxy's structure. But here's the haunting truth beneath that flawless precision. Every pulse is a lie. A cover story, the aftermath of violence so extreme it defies imagination. When a massive star dies in a supernova, its core doesn't just fade, it implodes with such force that protons and electrons are crushed together, forming a neutron star. And if that star is spinning, the result is a pulsar, its surface a solid crust of iron, its interior a superfluid of quantum chaos. The very regularity we admire is a mask for turbulence, a performance of order staged over a void of disorder. This cosmic duality mirrors one of humanity's most fragile coping mechanisms, the compulsive need for control. Think of the perfectionist who calibrates every minute of their day, the workaholic who mistakes busyness for stability, the survivor who builds routines as fortresses against past trauma. Like a pulsar, their outward rhythm seems unshakable, but beneath that steady pulse often churns a supernova's worth of unprocessed pain. The more precise the spin, the more violent the collapse that birthed it. Psychologists call this phenomenon overcompensation, our mind's desperate attempt to impose order where chaos once reigned. And just as pulsars slowly lose energy over millennia, their spins imperceptibly slowing, these human mechanisms also exact a toll. Exhaustion, isolation, the quiet erosion of joy. Consider the Vela pulsar spinning 11 times per second deep in the southern sky. Its flashes arrive with nanosecond accuracy, yet the nebula surrounding it tells another story, a tangled web of debris from the explosion that created it, still expanding outward at 500,000 miles per hour. The contrast is breathtaking, a mechanical perfection floating in a sea of wreckage. It's a mirror to anyone who's ever papered over cracks with productivity, whose immaculate spreadsheet hides a sleepless night, whose polished smile deflects questions about the shadows beneath their eyes. The universe understands this dance, it invented it, yet pulsars hold another secret, one that complicates their parable of control. Over time, some suddenly glitch, their spins briefly accelerating before settling back into rhythm. These anomalies baffled scientists for decades until they realized the star's rigid crust occasionally cracks, allowing the chaotic superfluid beneath to surge outward, nudging the rotation faster. It's a celestial admission that even the most controlled systems can't suppress their inner turbulence forever. The same applies to human hearts. Therapy sessions that unravel years of bottled grief, creative outbursts that shatter carefully maintained personas, moments of vulnerability that rewrite a life's trajectory. These are our glitches. And like the pulsars, they're not malfunctions, they're corrections. Perhaps that's why these spinning stars resonate so deeply. They're not just relics of destruction or marvels of precision, they're cosmic testimonials to resilience. A pulsar doesn't apologize for its past, it transforms it into something useful. Its pulses guide lost ships, its regularity tests fundamental physics. Even in its isolation, light years from another living thing, it beams a message to the universe. Chaos can be compressed, pain can be repurposed, and sometimes the most reliable light comes from what survived the darkest collapse. There comes a moment in every great cosmic story where the universe itself begins to forget. Not metaphorically, but literally, galaxies drifting so far apart that their light can no longer bridge the distance, stars receding into an unreachable horizon until one day the sky goes dark. This isn't science fiction. It's the inevitable consequence of dark energy, that mysterious force accelerating the expansion of space itself. Billions of years from now, civilizations, if any still exist, will gaze up at a night sky stripped of all but the faintest glow from nearby stars. The rest will have vanished, their light stretched beyond detection, their stories lost to the void. It's the ultimate cosmic forgetting, and in its slow, silent unraveling, we find an eerie reflection of our own fragile grip on memory. Picture a future historian trying to piece together the origins of their world, only to find the evidence has literally faded away. The light from distant galaxies, once a roadmap to the universe's past, now redshifted into oblivion. Entire chapters of cosmic history, erased not by fire or ice, but by the relentless stretching of space itself. This is the fate awaiting the universe, a gradual amnesia where even the evidence of other galaxies will disappear, leaving behind only whispers in the cosmic microwave background. It's a process that mirrors the cruelest of human conditions, Alzheimer's, where memories dissolve like sand through fingers, or the slow erosion of cultural heritage as languages die and traditions fade. The universe, it seems, is no better at holding onto its past than we are. Yet there's a strange comfort in this inevitability. The same force that will one day isolate galaxies is also what made life possible in the first place. Without dark energy's push, matter might have collapsed back into a primordial soup, never giving rise to stars, planets, or us. It's a cosmic irony. The very thing that will eventually erase the universe's history is also what allowed that history to exist. Like a parent who both nurtures and outlives their child, dark energy giveth and it taketh away. And that's where the lesson lies. In a universe destined for forgetting, the present becomes sacred. Every culture's oral histories, every family's photo albums, every scientist's painstaking records, they're not just acts of preservation, they're acts of defiance. The Maya carved their stories into stone. The Voyager probes carry golden records into interstellar space. Even our everyday rituals, birthday candles, anniversaries, the retelling of old jokes are attempts to anchor ourselves against the tide of time. The universe may not remember, but we can, for now. So when you next look up at the stars, remember this: you're witnessing a snapshot that won't last. The Andromeda Galaxy, that faint smudge of light, will one day be invisible to whatever eyes remain. But tonight, it's here, and so are you. In a cosmos racing toward amnesia, presence is the rarest gift of all. The sun isn't just a gentle provider of warmth and light. It's a seething ball of plasma, capable of temper tantrums that shake the solar system. Every 11 years, its surface erupts with sunspots, dark blemishes where magnetic fields twist and snap like rubber bands stretched too far. When these tangled fields finally release their pent-up energy, they hurl colossal bursts of radiation and charged particles into space, solar storms. The most powerful of these, called coronal mass ejections, can slam into Earth's magnetic field with the force of 1 billion atomic bombs. Satellites sputter. Power grids flicker and fail. Even the northern lights, those ethereal curtains of color, are just the visible scars of our atmosphere being battered by the sun's fury. What makes these cosmic outbursts so unsettling isn't just their destructive potential, it's their familiarity. Like a loved one whose kindness can curdle into rage without warning, the sun embodies a paradox we know all too well. The same force that nurtures can also devastate. A single well-timed solar storm could plunge continents into darkness, frying transformers and knocking out communications for months. Yet without the sun's daily generosity, life on Earth would freeze in hours. It's a celestial lesson in emotional volatility, how the brightest hearts sometimes cast the darkest shadows. History offers stark reminders of this duality. In 1859, the Carrington event, the most intense solar storm ever recorded, set telegraph offices ablaze and sparked auroras so bright, birds sang at midnight, mistaking the glow for dawn. Today, a storm of that magnitude would cripple modern infrastructure, causing trillions in damage. But here's the twist: these tempests aren't malevolent. They're simply the sun being the sun, its energy uncontained. Much like human anger, their danger lies not in existence, but in lack of preparation. We can't stop solar flares, just as we can't eradicate strong emotions. But we can build surge protectors for our grids and for our relationships. That's where the real parallel lies. Solar physicists monitor the sun's mood swings with satellites like the Solar Dynamics Observatory, issuing warnings before storms hit. In our personal lives, we have our own early warning systems: raised voices, clenched fists, the cold silence that stretches too long. The lesson isn't to suppress the heat, but to channel it. Astronauts shelter in shielded compartments during solar flares. Couples retreat to neutral corners during arguments. Both strategies acknowledge the same truth: survival isn't about avoiding storms, but weathering them with intention. Perhaps the most humbling detail comes from NASA's Parker solar probe, which flies closer to the sun than any spacecraft before it. Its findings reveal something unexpected. Even in the corona's million-degree chaos, there are moments of eerie calm, pockets where turbulence gives way to stillness. That's the sun's final gift to us, not a promise of perpetual peace, but proof that balance exists within the storm. After all, the same magnetic fields that trigger solar flares also shape the gentle solar wind, which cradles our planet in a protective bubble. Destruction and shelter born from the same fire, so the next time you feel anger simmering yours or someone else's, remember the sun. Its tantrums don't negate its light. They're part of its nature, just as passion and pain are part of ours. The key isn't to fear the heat, but to respect it, to build the emotional equivalents of Faraday cages and surge protectors. Because in a universe where even stars lose their cool, resilience isn't about avoiding the fire. It's about learning to dance in its glow. Some asteroids spend eons locked in deadly trajectories, hurtling toward planets, moons, or even their own obliteration in a fiery collision. But gravity, the universe's great puppeteer, sometimes offers an unexpected reprieve. A chance encounter with a passing planet's gravitational pull can yank an asteroid onto a new path, sparing it from destruction and granting it a fresh orbit. These aren't just random cosmic corrections, they're second chances written in the language of physics, where a single nudge can rewrite an asteroid's destiny entirely. Take the story of asteroid Apophis, once considered the most threatening near-Earth object ever discovered. Initial observations suggested a terrifyingly high chance of impact in 2029, but further study revealed a different fate, a near miss, thanks to subtle gravitational tweaks from Earth itself. What could have been a cataclysm became a celestial close call, a reminder that even the most seemingly fixed paths can bend. It's a cosmic parallel to the human experience of narrowly avoiding disaster. The job offer that arrives after a layoff, the diagnosis caught just in time, the relationship salvaged by a single honest conversation. The universe, it seems, shares our capacity for unexpected redemption. NASA's DART mission took this idea even further, transforming theory into action. In 2022, a spacecraft the size of a vending machine deliberately slammed into the asteroid Dimorphos, altering its orbit around its larger companion, Didymos. The impact wasn't just a scientific triumph, it was a philosophical revelation. For the first time, humanity proved that celestial fates aren't set in stone. They can be redirected with enough determination and precision. The implications ripple far beyond planetary defense. Think of the teacher who intervenes before a student drops out, the community that rallies around someone on the brink, or even the personal choice to break a destructive cycle. Like Dimorphos, our trajectories aren't always locked in. Sometimes all it takes is the right force at the right moment to change everything. Yet there's a haunting beauty in how these asteroids embrace their new paths. Unlike humans, they don't resist gravity's course correction. They don't cling to old orbits out of fear or habit. They simply yield to the pull, allowing themselves to be reshaped. It's a silent lesson in surrender, not as defeat but as trust in the possibility of something different. Maybe that's why these wandering rocks resonate so deeply. They're cosmic proof that destruction isn't the only outcome, that a single gravitational whisper can turn a collision course into an open road. That redemption isn't just a human idea, it's woven into the fabric of the universe itself. So the next time you feel trapped in your own inertia, remember Apophis and Dimorphos. The same forces that govern asteroids also stir within you the gravity of past choices, the momentum of habit, but also the quiet nudges that might still lead you somewhere new. The universe is full of near misses and redirected paths. Yours could be next. NGC 628 should be one of the most vibrant places in the cosmos. A classic spiral galaxy swirling with young blue stars and glowing pink nebulas where new suns are born. But peer into its heart and you'll find something unsettling. A center so dark and empty, it feels like the galaxy has been scooped out. Astronomers call it the phantom galaxy, not because it's ghostly, but because its core is a phantom limb, a space where something massive ought to be, yet isn't. The supermassive black hole that typically anchors galaxies like this, it's strangely quiet, as if asleep or gone entirely. What remains is a cosmic hollow, a silent eye in the storm of swirling arms. And in that emptiness, we see a reflection of one of humanity's most insidious struggles, the hollowness that lingers after loss, or the slow erosion of burnout that leaves us going through the motions while feeling nothing at all. This galaxy's contradiction is what makes it so haunting. Its outer regions blaze with star formation, those iconic spiral arms glittering with stellar nurseries. From a distance, NGC 628 looks alive, even thriving, but zoom in and the illusion shatters. The closer you get to its core, the fewer stars you find, until finally, nothing. It's the celestial equivalent of someone who laughs a little too brightly at parties while their eyes stay distant, or the high achiever whose productivity masks a growing numbness. Psychologists have a term for this: functional depression. The machinery of life keeps turning, but the center doesn't hold. NGC 628 isn't just a galaxy. It's a mirror held up to anyone who's ever faked a smile while feeling empty inside. Scientists are fascinated by this phantom core because it defies expectations. Most spiral galaxies are anchored by a bustling nucleus, a supermassive black hole feeding on gas, or at least a dense cluster of old stars. But NGC 628's center is eerily still. Some theorize its black hole starved to dormancy, its last meal so long ago that even the memory of that hunger has faded. Others wonder if something violent ejected it entirely, leaving behind a gravitational wound. Whatever the cause, the result is the same: a galaxy that performs vitality while hiding vacancy. It's a phenomenon we recognize all too well in human behavior, the way trauma can hollow a person out, or how years of unaddressed stress can turn passion into routine. The galaxy's outer beauty doesn't negate its inner silence, it accentuates it. Yet there's a peculiar hope hidden in NGC 628's story. Those thriving spiral arms aren't just a mask, they're proof that creation persists even when the center goes quiet. New stars keep being born in the periphery, their light a stubborn refusal to let the void win. Maybe that's the real lesson here. Healing doesn't always start from the inside out. Sometimes it begins at the edges, in small acts of defiance: the morning walk taken despite the fatigue, the old song sung softly in the shower, the decision to plant a garden even when joy feels out of reach. NGC 628 arms are still spinning. Its story isn't over, and neither is yours. Astronomers study this galaxy to understand what they call galactic midlife crises, the phase when a star system's core activity wanes while its outer regions remain active. But perhaps the term applies just as well to us. Midlife isn't just a chronological marker. It's any moment when the fire at our center dims, leaving us to wonder if we're more than just the sum of our motions. NGC 628 whispers a reminder: emptiness isn't the end. It's a phase, and sometimes the bravest thing we can do is keep spinning while we wait for the light to return. The universe isn't just a scattering of isolated galaxies, it's a vast, intricate tapestry woven together by threads of gas so thin they're nearly invisible. Scientists call this the cosmic web, a network of filaments stretching billions of light years, connecting galaxies like dots on a celestial circuit board. These delicate strands, made mostly of hydrogen, are the scaffolding of the cosmos, the hidden highways along which matter flows to feed growing galaxies. But here's what's truly astonishing. If you could zoom out far enough, this web would look eerily similar to the neural networks in a human brain, as if the universe and the mind are echoing the same blueprint. It's a humbling reminder that the bonds tying galaxies together aren't so different from the ones linking us to one another. These filaments aren't just poetic metaphors, they're lifelines. When a galaxy runs low on star-forming gas, it's these threads that deliver fresh fuel, like veins carrying oxygen to a muscle, but their fragility is their tragedy. A passing black hole or a violent galactic collision can shred these connections, leaving galaxies stranded, cut off from the nourishing flow. It's a cosmic parallel to how easily human relationships can frame, misunderstandings left unaddressed, time and distance left unchallenged until one day the connection snaps. We've all felt it, that moment when a friendship once taken for granted suddenly feels out of reach, or when a family bond weakens under the weight of silence. The cosmic web teaches us that isolation isn't just a human fear, it's written into the fabric of space itself, yet there's a breathtaking resilience in this design. Even when filaments break, the universe finds a way to rebuild. Gravity, that relentless sculptor, draws new strands over eons, patiently reweaving the torn connections. And isn't that what we do? A long overdue apology, a shared memory revisited, a hand extended after years. These are the human equivalents of gravity's quiet work. The cosmic web doesn't just mirror our struggles, it offers a lesson in patience. Some bonds take lifetimes to mend, just as some filaments take billions of years to reform. But the potential for reconnection never truly vanishes. What makes this web so emotionally resonant isn't just its fragility or its resilience, it's the sheer scale of its connections. Every filament whispers the same truth: nothing in the universe exists in isolation. The hydrogen atoms in your body right now once traveled along these very threads, passing through generations of stars before becoming part of you. You're not just a witness to the cosmic web, you're a product of it. And just as galaxies are linked across unfathomable distances, so are we. The colleague who changed your perspective, the stranger whose kindness lifted you on a hard day, the ancestor whose choices shaped your world. These are the invisible filaments of the human experience, tying us together in ways we may never fully see. So the next time you feel untethered, remember the cosmic web. Its filaments are frayed and reforged, just like the bonds between us, but their existence proves something profound. Isolation is an illusion. Whether in the vastness of space or the quiet of a solitary moment, we're all part of a network far grander than ourselves, one that hums with the quiet promise that no thread, no matter how thin, ever truly drifts alone. There's a cruel twist in the life story of stars like our Sun, one that turns their greatest act of nurture into an inevitable betrayal. For billions of years, a star like ours burns steady, its warmth cradling planets in the perfect zone for life to flourish. Earth owes everything to this stability: oceans that stay liquid, climates that evolve but don't scorch, the slow dance of seasons that allowed civilizations to rise. But this golden age is temporary. When the sun's core exhausts its hydrogen fuel in about 5 billion years, it won't just fade, it will swell into a red giant, its outer layers inflating like a dying breath until they engulf Mercury, Venus, and likely Earth itself. The same heat that once nurtured will incinerate. The light that sparked life will become its funeral pyre. This cosmic tragedy isn't just about destruction, it's about unintended consequences. The red giant phase isn't malicious, it's simply physics. The star, desperate to keep burning, begins fusing helium in its core, triggering violent convulsions that push its surface outward. There's no malice in this expansion, just the indifferent mechanics of stellar aging. Yet the result is the same: a parent devouring its children. It's a haunting parallel to human stories where love turns suffocating, where sacrifices meant to protect instead smother. Think of the immigrant parent working themselves to the bone to give their child opportunities, only to resent the independence that success brings. Or the well-intentioned activist so focused on a cause, they bulldoze personal relationships in its name. The road to unintended consequences is paved with good intentions, whether in stars or souls. Astronomers call this process planetary ingestion, but the clinical term belies its emotional weight. When scientists simulate the sun's red giant phase, they find Earth might not go quietly. Some models suggest our planet's orbit could decay slowly, spiraling into the sun's outer layers over millennia, subjected to increasing heat and tidal forces until it vaporizes. Others propose a darker fate. Earth could be flung outward by the sun's mass loss, an orphaned world frozen in the dark. Both scenarios carry a gut-wrenching irony. The very star that gave Earth life would either consume it or abandon it. There's no winning move, just degrees of loss. Yet within this inevitability lies a strange comfort. The elements forged in the sun's death throws carbon, oxygen, even traces of gold will be scattered into space, eventually seeding new stars and planets. The same is true of human legacies. A family business might collapse under the weight of generational expectations, but the skills learned there could inspire a grandchild's groundbreaking career. A relationship strained by overbearing care might fracture, yet the love within it could shape how someone else chooses to love. Destruction and creation spiral together, two sides of the same coin. Perhaps that's the red giant's final lesson. Regret is inevitable when time stretches long enough, but so is renewal. The sun won't choose to swallow its planets any more than a parent chooses to stifle a child's growth. Both are caught in forces larger than intention, one by gravity and fusion, the other by fear and hope. The universe doesn't judge these outcomes, it simply unfolds them, offering no moral except the one we choose to see. And if even stars must reckon with the unintended costs of their light, maybe we can forgive ourselves for doing the same. Somewhere in the universe, two black holes spiral toward each other in a dance older than time itself. Their gravity warps the fabric of space around them, sending invisible ripples racing outward at the speed of light. Not sound, not light, but vibrations in space-time itself. These are gravitational waves, the universe's most haunting love letters, written in the language of distortion. When they finally reached Earth on September 14, 2015, after traveling for 1.3 billion years, the Laser Interferometer Gravitational Wave Observatory LIGO caught their whisper. The signal lasted just 0.2 of a second, but in that fleeting moment, humanity witnessed something profound, proof that even the most hidden wounds leave echoes that outlast their source. What makes these ripples so emotionally resonant isn't just their cosmic scale, it's their intimacy. The black holes that birthed them were stellar ghosts, long since vanished, their collision over before dinosaurs walked the Earth. Yet their aftermath still rippled through LIGO detectors, a delayed reaction to violence no living being witnessed. It's a celestial parallel to how childhood traumas, buried for decades, can surface in a therapist's office, or how a single harsh word from a loved one lingers long after the argument ends. The universe, it seems, remembers, not with nostalgia but with physics. Every scar, every fracture, every gravitational shudder leaves its mark on the fabric of what comes next. The numbers behind this event are staggering. The two black holes, each roughly 30 times the mass of our Sun, circled each other hundreds of times per second before merging in a cataclysm so violent, it momentarily outshone every star in the observable universe combined. Yet what LIGO detected wasn't the light or heat, it was the way their collision stretched and squeezed spacetime itself, warping the laser beams in its detectors by less than 1,000th the width of a proton. That's the eerie precision of trauma's fingerprint, invisible to the naked eye but measurable in the way it bends everything around it. Scientists call these signals chirps, a gentle term for something born of such violence. When converted to sound waves, the merger rises in pitch and amplitude before ending abruptly, like a bird's call cut short. There's a heartbreaking duality to that sound. On one hand, it's the death cry of two cosmic monsters. On the other, it's the first clear evidence that space-time isn't just a static stage. It's a dynamic, responsive thing, quivering like a drumhead when struck. Trauma operates the same way. It doesn't just happen, it reshapes the landscape of the mind, altering how future events resonate within us. Yet here's the twist hidden in LIGO data. Those ripples didn't stop after the merger. They're still spreading, still faintly vibrating the cosmos, even as you hear these words. The event is ancient history, but its repercussions are ongoing, a reminder that healing isn't about erasing scars, it's about learning to live with the tremors. Therapists call this post-traumatic growth, the idea that wounds, while painful, can also create new capacities for empathy, resilience, or insight. The universe agrees, those gravitational waves didn't just carry destruction, they carried information, teaching us about black hole masses, spin rates, even the rate of cosmic expansion. Perhaps that's the most humbling lesson here. When we say trauma leaves marks, we often frame it as damage, but LIGO chirps tell a different story. Those ripples are also messengers carrying truths across billions of years. The same is true of human pain. It distorts, yes, but it also reveals. The anxiety that makes someone hypervigilant might also make them astonishingly perceptive. The grief that hollows can also carve space for deeper connections. Like space-time itself, we're not just passive victims of the forces that shape us. We're dynamic, resonant, capable of turning even the most violent collisions into something that, one day, might help another find their way. There's a quiet revolution unfolding in cosmology, and at its heart lies a number that refuses to add up: the Hubble constant, the rate at which our universe expands. On paper, calculating it should be straightforward. Measure how fast galaxies recede from us, factor in their distance, and voila, you've got the expansion rate of the cosmos. But here's the cosmic curveball. Two of science's most trusted methods keep yielding different answers. One approach, using the flicker of ancient starlight from the early universe, suggests a slower, more stately expansion. Another, counting the pulses of nearby stars, insists the universe is sprinting apart faster than we thought. The discrepancy isn't a rounding error. It's a gaping chasm, one that sent physicists scrambling for answers. They call it the Hubble tension, and it's more than just a technical glitch. It's a mirror to the human condition, where truth often fractures along the lines of perspective. Imagine two detectives at a crime scene, each examining different clues. One studies fingerprints on a window, the other analyzes tire marks in the driveway. Both are meticulous, both are certain, yet their conclusions clash. The Hubble tension unfolds similarly. Cosmologists peering into the infant universe via the cosmic microwave background see a cosmos expanding at 67 kilometers per second per megaparsec. Meanwhile, astronomers tracking pulsating stars in nearby galaxies clock the rate at 73. That 6-kilometer gap might seem trivial, but in the precise world of astrophysics, it's seismic. It's like two clocks in the same room ticking at different speeds. Eventually, you'd question whether time itself is broken. This isn't just academic quibbling. The tension threatens to unravel our understanding of cosmic history. If both methods are correct, then somewhere between the universe's first light and today, something fundamental changed. Maybe dark energy, the mysterious force accelerating expansion, isn't constant after all. Perhaps unknown particles flit through space, tweaking gravity's rules. Or could there be an error in our measurements, a hidden bias neither camp has spotted? The debate grows heated because it's not just about numbers, it's about how we perceive reality. The Hubble tension is the scientific equivalent of a family argument where everyone's right, yet no one agrees, and that's where the deeper parallel emerges. Human conflicts often stem from partial truths masquerading as absolutes. Two people recounting the same event will emphasize different details, filtered through their experiences. A protest might be a cry for justice to one observer and a threat to order to another. Neither is lying, they're just measuring different facets of reality. The Hubble tension reminds us that even in science, where data reigns supreme, interpretation is everything. The cosmos isn't being coy, it's showing us that some truths are layered, revealing themselves only when we're willing to question our tools, our assumptions, even our math. What's astonishing is how scientists are responding. Some are overhauling cosmology, proposing exotic fixes like early dark energy or tweaks to Einstein's equations. Others are double-checking their cosmic yardsticks, hunting for overlooked errors, but the most radical idea that both camps might need to surrender their certainty. Just as therapy often reveals how both parties in a conflict contribute to the stalemate, the Hubble tension might demand physicists admit neither method has the full picture. The solution could lie in a third way, a new framework that bridges the divide. Much like empathy transforms deadlocked arguments into dialogue, there's a poignant lesson here for all of us. The universe's expansion rate isn't just a number, it's a test of intellectual humility. Whether in science or personal strife, the hardest truths to grasp are the ones that force us to re-examine our foundations. Maybe the cosmos isn't broken. Maybe we are tethered to our limited vantage points, mistaking our slice of reality for the whole. The Hubble tension, in all its frustrating glory, is a cosmic invitation to listen more closely, measure more carefully, and stay open to the possibility that truth, like the expanding universe, is richer than any single perspective can contain. The Moon has been Earth's silent companion for over 4 billion years, a steadfast witness to every sunrise, every extinction, every human story ever told. But this cosmic friendship isn't as permanent as it seems. Right now, as you read these words, the Moon is drifting away from us, not in some poetic metaphor, but in cold, hard physics. Every year, it recedes another 1.5 inches, carried outward by the same tidal forces it helps create. It's a slow separation, barely noticeable in a lifetime, but over millennia, it adds up. Eventually, Earth's skies will grow darker, its tides weaker, its nights lonelier, and in that gradual retreat, we find a mirror to one of life's quietest heartbreaks, the friendships that fade not with drama, but with the weight of unspoken distance. Think of the last time you let a connection slip. There was no fight, no final goodbye, just the slow accumulation of unanswered texts, postponed coffees, birthdays left uncelebrated until one day you realize you've become strangers. The Moon's departure works the same way. Its gravity pulls Earth's oceans, creating tides that bulge slightly ahead of the Moon's orbit. That bulge, in turn, tugs the Moon forward, giving it a tiny energy boost that pushes it farther away. It's a cosmic feedback loop. The Moon's love creates the force that drives it away. Isn't that how so many relationships unravel? The very closeness that once bound two people becomes the inertia that pulls them apart. Yet the Moon carries its own scars of loyalty. Its pockmarked surface is a museum of collisions, asteroid impacts frozen in time, some dating back to the solar system's violent infancy. Unlike Earth, where wind and water erase old wounds, the Moon has no atmosphere to weather its history. Every crater remains, a silent testament to the blows it's endured while standing guard over us. It's a reminder that even in drifting apart, there's permanence in what was shared. Those craters are like the memories we cling to long after a friendship fades, the inside jokes that still make you smile, the advice that echoes in your decisions, the moments that shaped you even if the person who shared them is no longer there. Here's the bittersweet twist: the Moon's retreat isn't infinite. Billions of years from now, when the sun swells into a red giant and Earth's oceans boil away, the tides will cease. Without that gravitational push-pull, the Moon will stop drifting. It'll settle into a distant but stable orbit, a companion once again. Just as some friendships, after decades of silence, find their way back to a quieter, steadier connection. Maybe it's a chance reunion, a shared grief that bridges the gap, or simply the recognition that time has sanded down old edges. The universe has a way of balancing its equations, even if the variables change. So when you next see the Moon hanging low and luminous, remember this: it's not just a rock in the sky. It's a celestial diary, its surface etched with the history of its loyalty, its slow retreat a lesson in the physics of love and loss. The same forces that pull it away also shape the tides that gave rise to life. And just maybe, the friendships that drift from us leave their own invisible tides, currents that continue to move us long after the shore is out of sight. The universe should be buzzing with life, with hundreds of billions of galaxies, each containing billions of stars and planets. The numbers alone suggest we should have heard something by now, a radio signal, an artifact, some whisper of another civilization reaching out. Yet the cosmos remains eerily silent. This is the Fermi Paradox, the unsettling gap between the high probability of alien life and the total absence of evidence for it. Named after physicist Enrico Fermi, who famously asked, "Where is everybody?" This paradox isn't just a scientific puzzle, it's a mirror to one of humanity's deepest existential aches, the fear that no one is listening, that our calls into the void might never be answered. Think of it like standing in a crowded room, shouting for a friend. At first, you assume they'll answer until the silence stretches and doubt creeps in. Are they ignoring you? Did they never enter the room at all? The Fermi Paradox forces us to confront similar questions on a cosmic scale. Maybe civilizations are hiding, wary of drawing attention in a dangerous universe. Perhaps they've transcended physical communication, their signals lost in technologies we can't comprehend. And this is the most haunting possibility, maybe intelligent life is vanishingly rare, and we're the only ones here to wonder. The implications ripple far beyond astronomy. If the universe is empty, it means every song, every painting, every act of love or war has unfolded on a single stage, with no audience but ourselves. It's a loneliness so profound, even Earth's vast oceans and sprawling cities can't dilute it. Yet there's another side to this silence. The absence of alien contact might not mean abandonment. It could be a form of protection. Some theorists suggest advanced civilizations deliberately stay quiet, avoiding interference with younger species until they're ready. It's the cosmic equivalent of a parent letting a child explore the world without hovering, trusting they'll find their own way. The paradox also forces us to question our assumptions about intelligence itself. We scan the skies for radio waves because that's how we communicate. But what if other civilizations use neutrino beams or quantum entanglement? Our tools might be too primitive to detect their presence, like trying to catch a symphony with a tin can telephone. Or perhaps intelligence isn't the pinnacle of evolution we assume it is. On Earth, countless species thrive without technology. Maybe the universe is full of life, just not the kind that builds telescopes. This isn't just about aliens. The Fermi Paradox holds up a mirror to our own struggles for connection. How many times have you reached out only to be met with silence? A text left unanswered, a confession unreciprocated, a dream shared and dismissed. The universe's quiet mirrors those moments, amplifying the question, does anything we do matter if no one is there to witness it? But here's the twist hidden in the paradox. The very act of searching, of pointing radio telescopes at distant stars, of sending probes to Mars, of wondering, is a rebellion against indifference. Even if we're alone, our curiosity ensures we're not passive. We're the universe observing itself, finding meaning in the asking. So the next time you look up at the stars and feel the weight of their silence, remember this: absence isn't the same as emptiness. The universe might be quiet, but it's listening, and whether we're truly alone or simply waiting to be found, the search itself is what makes us alive. The Fermi Paradox doesn't just ask where the aliens are, it asks why we care, and in that question we find our answer. What if somewhere out there, in the vast expanse of reality, another version of you made all the right choices? The career leap you hesitated to take, the relationship you walked away from, the words you swallowed instead of speaking, all playing out differently in some shimmering parallel universe. The idea of the multiverse isn't just a sci-fi fantasy. It's a cutting-edge theory in physics, where infinite variations of our world branch off with every decision, every chance encounter. But here's the catch: if every possible outcome exists somewhere, then so does every regret. The multiverse doesn't just offer escape routes, it magnifies our what-ifs into something far more haunting. A cosmic FOMO, where the life you didn't choose isn't lost to time, it's out there, taunting you from another dimension. Think of Schrödinger's famous thought experiment, where a cat in a box is both alive and dead until observed. The multiverse takes this further. The cat isn't just in two states, it's in all possible states, each unfolding in its own separate reality. Your doppelganger who boarded that plane instead of missing it might be sipping coffee in Paris right now. The version of you who said yes to that risky startup could be lounging on a private island. It's exhilarating and gut-wrenching in equal measure, like scrolling through an ex's vacation photos while you're stuck in traffic. The universe isn't just indifferent to your choices, it's running a highlight reel of all the ones you didn't make. But string theory offers a strange sort of solace. If every possible timeline exists, then no path is truly abandoned. The artist who gave up painting to raise a family might be a celebrated creator in another world. The astronaut who washed out of training could be planting flags on distant moons elsewhere. There's no a wrong choice, just different forks in an infinite road. It's the ultimate antidote to indecision. No matter what you pick, some other you pick differently. The pressure to optimize every life decision melts away when you realize you've already done it all, just not here. This isn't just physics, it's philosophy in a spacesuit. The multiverse reframes regret not as failure, but as curiosity. That nagging sense of what if becomes less about mourning and more about marveling at the sheer scope of existence. Maybe parallel universes explain déjà vu, those fleeting moments when reality glitches and you swear you've lived this before, or why dreams sometimes feel like visits to other lives. The boundaries between science and poetry blur when you consider that every crossroads you've ever faced still stretches onward somewhere, its untaken path glowing like a street lamp in another world's rain. Yet there's a danger in leaning too hard on this cosmic safety net. If every possibility plays out somewhere, does anything truly matter? The answer lies in the one universe you're certain exists, this one. The multiverse isn't a hall of mirrors, it's a hall of doors. And while it's comforting to imagine other versions of you thriving behind them, the version reading these words is the only one who gets to feel the weight of this keyboard, the warmth of this screen, the bittersweet ache of being exactly here now. Regret isn't proof you chose wrong. It's proof you cared enough to wonder, and in a cosmos teeming with alternate realities, that might be the most human thing of all. The universe is dying not with a bang, but with a whisper. Scientists call it heat death, the inevitable future when all energy disperses evenly across space, stars burn out, and the cosmos becomes a vast, lukewarm graveyard. No more galaxies swirling, no more stars igniting, just an endless expanse of particles too far apart to interact, drifting in perfect, lifeless equilibrium. It's the ultimate thermodynamic melancholy, a fate so bleak it makes black holes seem cheerful by comparison. And yet, this slow unraveling holds a mirror to one of humanity's oldest fears, that nothing we do matters in the grand scheme of things. If the universe itself is fated for oblivion, what's the point of any of it? But here's the paradox hidden in this cosmic doom. The very inevitability of entropy, the universe's irreversible slide toward disorder, is what makes the present so breathtakingly precious. Think of a sandcastle on the beach. You know the tide will eventually wash it away, but that doesn't stop you from marveling at its intricate towers, or feeling the grit of the sand between your fingers as you build. The same applies to the cosmos. The fact that stars won't shine forever is what makes their light so worth savoring now. The knowledge that one day, every book, every symphony, every act of love will be erased by time doesn't diminish their meaning, it sharpens it. Consider the Hubble Ultra Deep Field image, that famous snapshot of a seemingly empty patch of sky teeming with thousands of galaxies. Each one contains billions of stars, countless worlds, and untold stories. Yet in trillions of years, those galaxies will have receded beyond the cosmic horizon, their light too faint to detect. The universe will forget them, just as it will forget us. But here's the twist: forgetting isn't the same as being forgotten. The warmth of a campfire doesn't cease to matter because the embers will cool. The laughter shared between friends doesn't lose its joy because the moment passes. Heat death isn't a cancellation of meaning. It's a reminder that meaning has always been local, fleeting, and achingly human. This isn't just philosophy, it's physics with emotional resonance. The second law of thermodynamics, which dictates entropy's rise, is often framed as a cosmic downer, but flip the script and it becomes the ultimate motivator. If the universe is a clock winding down, then every tick is a chance to create, connect, or rebel against the silence to come. Artists know this instinctively. A song fades, but we still sing. A sculpture crumbles, but we still carve. The heat death of the universe is just the longest fade out in history, and we're the music playing against the dying of the light. So the next time you feel small against the cosmos, remember, the universe may end in cold dispersion, but right now, it's alight with heat and motion. The very particles in your body were forged in stellar furnaces that no longer exist. You are quite literally stardust refusing to settle. And if that's not a reason to live fiercely, lovingly, and with defiant curiosity, what is? The end may be written, but the story is still ours to tell. From the explosive demise of stars to the silent drift of rogue planets, we've traveled through 25 cosmic crises that feel startlingly human. These aren't just distant celestial events, they're mirrors held up to our own joys and sorrows, written across light years in the language of gravity and stardust. When a supernova scatters the elements of life across the void, or when galaxies collide in violent rebirth, we're witnessing more than physics. We're seeing the universe express the same narratives that play out in our own hearts: resilience in the face of destruction, connection amidst isolation, and the stubborn persistence of light in the darkest places. Carl Sagan's famous words take on new meaning through these cosmic parallels. We don't just study the universe, we're its living archive. The iron in your blood was forged in the heart of a dying star. The calcium in your bones was distilled in some ancient supernova. Your very atoms carry the fingerprints of celestial events that occurred billions of years before Earth existed. When you feel grief over a fractured relationship, remember the binary stars teaching us about unbalanced bonds. When you wrestle with change, recall Andromeda and the Milky Way, two giants destined to merge into something entirely new. Your struggles aren't small because the cosmos is vast. They're profound because they echo its oldest patterns. This revelation doesn't diminish our problems, it elevates them. The next time you stare at the night sky, know this: you're not separate from those distant points of light. You're their continuation. The same forces that sculpt galaxies flow through your decisions. The same resilience that keeps a neutron star spinning against impossible odds lives in your capacity to endure. Even loneliness, that most human of pains, finds its counterpart in the cosmic web's severed filaments or the orphaned pulsars' fading signals. The universe has been rehearsing these emotions since the first stars ignited. So tell us in the comments which cosmic crisis spoke to your own story. Was it Beetlejuice's defiant final act, or Europa's hidden ocean persisting against all odds? The conversation doesn't end when this video does. Every glance upward is a chance to rediscover your place in this grand, star-strewn drama. Because you aren't just made of stardust, you're made of the universe's deepest memories, its hardest lessons, and its most enduring hopes. And that makes you, and every choice you make, part of the cosmos' ongoing masterpiece.